We've completed most of the algorithm and shader. For this video, I will be detaching shell design to separate object and node tree. As preparation, let's pin the node tree so even if we select another object, it doesn't disappear. Next, let's start properly naming objects. Rename plane to launcher, and rename its geometry node to fireworks. Let's also revert the direction to vertical as well. Then, let's add a new collection into scene collection, so we can keep all the shell objects in one location. As you may have noticed, the shape of this firework is currently determined by this icosphere. So if I were to increase the subdivision to 2, number of stars will increase along with the increased vertex count. This also does not need to be geometry node generated icosphere. I'm going to add an icosphere to shell collection and drag and drop in the map. If I connect this object info node up to mesh to points, then it will behave the same as before. Now, I'm going to sort and relocate attributes. So there are a fair amount of store named attributes in init shell node group. But we can categorize them into specification or spec data, which defines a characteristic and is static during animation, and runtime data, which is updated during animation. Between these two, I'm going to relocate the specification data to icosphere side. First, let's add new geometry node modifier to this icosphere. Click on new and call it shell builder. Next, let's open up a new pane by dragging the window corners. Unpin by clicking this button, and make sure the map is now showing shell builder. Then repin. Since real estate is scarce, let's display as full screen by pressing Ctrl space. First, add an init shell node group, and make sure side panel is open as well. I'm going to be copying spec data arguments from the node group. First, shell radius is the spec data. Drag out a line and connect it to empty socket of group input. Initial mass is also a shell spec. Initial speed, position, and spawn timings are determined in runtime, so we don't need them. Shell lifetime is specification, so add it as well. So is shell and tail lifetime. Shell ID is a runtime data, so skip over it. The rest are all spec data, so add them to arguments. So we're left with spec data for group input arguments. I'm just going to cut all these connections here. And next, select the init shell. Use W to open up the node options, then ungroup. Let's reorganize a bit. Okay, let's connect the arguments as we sort out the spec data. First, rad is shell radius, and mass init connects to initial mass. Mass, vel, pods are runtime data. Delete them with Ctrl X. T-shell spawn, T-shell burst are also runtime. Delete them. B shell connects to is shell. Tail lifetime connects to the same name argument. Delete shell ID. Rest of them connects to tail end radius, head color, tail color, head emission strength, tail emission strength. Then connect group output to the end. We should end up with 9 store name attributes, but we'll add one more to make it 10. Duplicate tail lifetime and rename it to shell lifetime. Connect its input to shell lifetime. Then select only the group inputs and Ctrl H to hide unused sockets. It's easier to check connection this way. Get out of full screen mode by pressing Ctrl space, and let's set the parameters. Shell radius to 0.01, initial mass to 0.005. Shell lifetime to 1, is shell to false. Tail life to 1, tail end radius to 1. Apply any color of choice to head and tail color. I'm going to set head and tail emission to 150. Now, I'm going to start making some changes to Fireworks init shell. First, click on this number to duplicate. Then, rename the node group to init shell RT. This way, the original node group is not affected. Then, this time, we'll leave the runtime data and delete the spec data. First, delete rad and mass init. Mass, vel, pause, t-shell spawn, t-shell burst should remain. And delete b shell. Delete tail lifetime as well. And leave shell ID here. Rest of them should be deleted. Let's reorganize. These 6 store named attributes should be remaining. Next, open up the side panel by pressing N, and we'll work on the arguments. Leave initial velocity, initial position, shell spawn timing, and shell ID, but rest should be removed. In the node tree, there should be 2 empty group inputs now. Delete them and replace the first one with named attribute mass init. For the one that connects to add, connect named attribute shell lifetime. Press tab to exit. Node group looks much smaller now. Now let's run the animation. If the relocation was done correctly, there should be no change in its behavior. Next, let's also detach the first point that gets launched and change its init shell as well. The same way that we did with the icosphere. First, add a plane to the shell collection. It's difficult to see, so let's press backslash on numpad to isolate. Go into edit mode and press M to merge. Select to center and merge it down to 1 point. It is hiding under this 3D cursor, but it is there. Switch back to object mode and remove the isolation. Next, add a shell builder geometry node on the plane object. Then set the parameters. Shell radius to 0.075, shell mass to 1.3, shell lifetime to 4, is shell to true, tail lifetime to 1, tail end radius to 0, any color for head and tail, emission strength to 1000 and 500. Then, add the plane object to Fireworks node map. Delete the points node. Pull out a mesh to points from geometry socket and convert points to vertices. Then, connect it to geometry socket of init shell. Next, from this dropdown of init shell, choose init shell RT to convert. Now the first shell has also been detached. Let's run the animation to make sure everything still works. Alright, seems like it's okay. Okay, so the point of today's video was to split the original geometry node into different objects without breaking the Fireworks system as a whole. Now, if we want to say change the color of the bursting stars, we no longer have to change anything in the Fireworks geometry nodes, but only have to make small changes to these shell objects. We've successfully been able to move towards making a variable Fireworks generator. Alright, with that, I'm gonna summarize and wrap up the video. First, within the outliner, we applied a name to the launcher object and added a shell collection along with 2 shell objects. We changed the geometry node name to Fireworks. Shell objects also hold geometry node of shell builder. Their parameters are as follows. Within the Fireworks geometry nodes, we've modified these 5 nodes. Within init shell RT, we left the runtime attributes and removed the rest. Within Shell Builder, the spec data attributes were relocated here. For the next video, I will be going over the concept of level and layer of Fireworks shell, which will allow us to design more complicated fireworks. Thank you for watching and see you next time.